We have one question from the chapter Maxima Minima. The question says that show that the right circular cone of least curved surface area, the surface area is what we have to minimize, and the given volume, that means the volume is fixed here, has an altitude equal to √2 times the radius. That means the to prove part is, we have to prove that height is equal to √2 times the radius. So let's begin with drawing the figure here. Say if I make a cone, and then we have to make its a circular base. Right. And we have its height. Let's say this being the height here. So know that height is perpendicular to the radius. This is the slant height. This is h here. This is the radius. So this is the reason why we have r square is equal to L square is equal to r square plus h square. Now we have been given the volume as fixed, so I can write volume, which is of a cone is 1/3 pi r square h. So we got this figure and the formula. Now let's see what we have to minimize is we have to minimize the curved surface area. So I can take the curved surface area as C, and curved surface area is pi RL. Now, as you can see that we need substitution here. I have to replace L or R. I go for replacing L, but we have L in terms of square, so it's better if I square both sides and then do substitution. Now I can replace this L square, right? I can replace this L square from here. So what we'll get here, this is C square is equal to pi square R square, and I'm replacing L square, which is R square plus H square. Now still the variable remains 2 only, and we know that V is the constant here, so we have to write in terms of V. So what we'll get V from here, like if I have to replace, I can see H will be cross multiplication, 3 will be multiplied with V and over pi R square. But we need H square, so I'll do squaring here only. So H square is equal to 9 times V square over pi square R square. So here we are going to do substitution. Let's say C square only, and this is pi square R square. This is R square again, plus this H square, as I said, H square from here, I can write this as 9 times V square over pi square R square. Now, if I open this bracket using distributive property, this is pi square R square multiplied by R square is R raised to the power 4, plus if I multiply this pi square, I can say this pi square will get cancelled in this case. And this was R raised to the power 4. This is squaring both sides, so it should give you R raised to the power 4, not R square. This is R raised to the power 4. So we can say that this R square and R4 get cancelled also. So what we'll get here? Now we'll get here as 9 times V square over pi square, as I said, get cancelled, and 1 R square is left over here. It is R square. Now we'll take, let's say, we are replacing C square as Z. So you can just write a statement putting C square as Z. As C square minimizes, Z will also minimize. Then I'm going to find its derivative, say dz by dr with respect to r. From here, I'll get 3r square, right? 3r square. Oh, 3r is 3r square. No, 4r raised to the power 3. And then this is pi square being coefficient. The 9v square is coefficient. You should know 1 over r square is actually r raised to the power -2, whose derivative is -2. R raised to the power -3, that is -2 over r raised to the power 3. So this, if I multiply, I multiply with this, So what we'll get? We'll get this as minus 18 over 18v over r raised to the power 3. So I'll instead write over here, this is minus 18. This is minus 18v over r raised to the power 3. Now we'll also find its double derivative before equating with 0. That can reduce the time involved. So I'll find d squared z by dr squared. The derivative of this is what? 4 3s are 12. 12 r square. And there is a pi square also, minus 18v. Now once again, this is 1 over r raised to the power 3, which is what? R raised to the power minus 3, that is minus 3 r raised to the power minus 4, that will give you minus 3 over r raised to the power 4. And if I multiply with this, we have, once again, I'll show you that is, we have 1 by r cube, whose derivative is what I just wrote as r raised to the power minus 3, which is minus 3 r raised to the power minus 4. So it's minus 3 over r raised to the power 4. And that multiplied by minus 18v. So in turn, we're going to get is positive 54v over r raised to the power 4. So I'm removing this and instead writing this over here. That is, this is 54 is a plus sign because there was a minus here and that multiplied with minus. We got the double derivative, and the next part is to equate f dash x with 0 so as to get the critical point. So the critical point, for finding the critical point, I need to equate this with 0. Now if I equate, I just need to write for maxima minima. You may write down the statement in the exam. I can simply write dz by dr equal to 0. If I equate this with 0 and transpose it simultaneously, we'll get 4r cube pi square is equal to positive 18 times v over r raised to the power 3. Now I'm transposing this r raised to the power 3 to the left hand side. So it's 4 pi square and r raised to the power 6 is equal to 18 times v. This v, again, I'm replacing with this volume formula. The volume formula is this. So I can write this as 18 and the v is replaced with 1 by 3 pi r square h. That's the v here, right? Is it v or v square? It's v square, I can see. This is v square here, right? So the v square will be square of this. That means I have to write the square of this. That is 1 by 9 pi square r raised to the power 4 and h square. Now for further calculation, I can reduce this by 2 times. I can see that even pi square get cancelled. With 2, this can be cancelled by 2 times. And r raised to the power 4 cancelled to give you r square. So in turn, we'll get what? 2r square. And on the other side, we have h square. So on transposing square to the left-hand side, the square, I can see h will be equal to 2 root r. But that's what we have to prove. But this is not the end of the sum, as we have to show that the double derivative at r is equal to this is what? Maxima or minima. We have to find the least surface area. That means we have to minimize. Minimize is what? We have to show this is greater than 0. So I'm doing this. I'm replacing r square over here. So this is d square z over dr square is equal to 12. This is r square from here. That is r square from here is h square by 2 pi square plus 54, v being constant, so we don't have to replace. This is r raised to the power 4, which will be what? r square is this, so r raised to the power 4 is h raised to the power 4 by 4. Well, you can see that here we all have positive values, right? These are all positive values. Therefore, it has to be greater than 0. Hence, it is maximum. Hence, maximum at, you can say at h square is equal to, or you can say h is equal to root 2. That's fine. At h is equal to root 2 r. So this is how we will do this question.